Okay, hi guys. So in this lecture, we'll be talking about uh, we'll be continuing on seeing more reactions of Grignard reagents. And before that, let me make a note. Like actually, ketone is more reactive than ester towards nucleophiles. This actually we saw in previous lecture also, wherein we were comparing the rate of different compounds towards nucleophiles. So just writing them in words that ketone is more reactive than ester towards nucleophile. Okay, and why is this the case? Because ester is will be stabilized by uh, the lone pair from the neighboring oxygen atom, which then can be used in resonance. Okay, and second point is formaldehyde is more reactive than aldehyde towards nucleophile. More reactive than aldehyde towards nucleophile. Why? Because obviously this actually has alpha hydrogen and then can have a hyperconjugation, whereas this has no alpha hydrogen, hence this has more delta positive character, hence a better choice for a nucleophile to attack on. Okay, now let us see some examples. So we have something like this, and we are reacting it with, let's say, x moles of CH3 MgBr, and we are also in acidic medium. So what is the let's suppose this is OH. Okay, so what would be the product formed? Okay, so the product formed is given, and this is something like this. So how many moles of let me erase it. So how many moles of CH3 MgBr would be used in this case? If your answer is 2, then you are perfectly wrong. Okay, so if you observe closely that we have OH also attached here, so this is also a acidic hydrogen. So 1 mole of CH3 MgBr, CH3 minus would also be attacking this. Okay, so it would form something like O minus, and obviously this would be, let's say, OH is formed with 2 moles of CH3s, CH3 MgBr. 1 mole of CH3 MgBr was actually extracting H plus from this acidic alpha hydrogen, or acidic hydrogen, not alpha hydrogen. So 1 mole was used here, CH3 MgBr. This will again actually have, due to we are having the presence of acidic medium, it will again actually capture OH here. Okay, and this is obviously uh, after after this we actually remove CH3 MgBr from the reaction itself. Okay, so that uh, no further attack of CH3 MgBr goes on either this hydrogen or on this hydrogen. Okay, so the correct answer would be x is equals to 3. Okay, so how many, now the next question is how many moles of Grignard will be consumed when the following compounds react with Grignard reagent? So following this example only, we have next question as how many moles of Grignard reagent will be consumed when the following compounds react reacts with Grignard. Okay, so let's see. So we have first in the series of this question, first example in the series of this question is we have something like this. So how many moles of Grignard would be consumed here? When we react this, obviously we are providing acidic medium afterwards, so one would be here, okay, because of this hydrogen, okay. One would be here, okay, because it has no leaving group, so only there is a scope of one CS3 to be getting attached on this carbon atom. As a result, O will have a negative charge, which upon hydrolysis will convert into OH, okay. We can have actually two here. Why? In one case it can leave, another it would another, so it would create a CS3 here, and in the second case again the O can take negative charge on itself, so hence 2 CS3 can be getting attached to this carbon atom. So answer would be 4. Okay, second example is we have something like this. So how many in this case? So this can actually have one here, in which N will take the negative charge, and upon hydrolysis the bond will break into OH, OH and HH on both the sides. So this can take one here, and this can take also one here. Okay, so the total answer in this case would be 2. Okay, so let's see some more examples here. So what if we actually don't that was the case when we actually passed on S3O plus in the solution, but what if we don't pass S3O plus in the solution? What would be the case then? So we would have something like, on this carbon, on this group where I'm talking about, we'll have something like N negative here, and we are just not in the previous case we actually saw the hydrolysis also, but in this case we are just passing it through acidic medium, we are not hydrolyzing it. So in that case we would have something like this, let's say this is R, okay, and we hydrolyze it, we'll get something like NH double bond C. One is used here, okay. Now again we use CH3 MgBr, okay, so we'll get something like, again we'll get NH negative and C, 2 CS3 attached, and now and R here, again we actually pass H plus, so we'll get NH2, and again CS3 and R, again we pass third mole of CS3 MgBr, again we'll get something like NH3, okay, and NH2 first, let's say, okay, NH3 and negative charge here, and we'll get something like 3 CH3s here, and the R group. Finally what will happen is, okay, so after this, is there any possibility of attaching more NH3 here or CS3 here? No. So only 2 will be possible, because we have already fulfilled the 4 valencies of carbon here. No unfulfilled valency is left. So in this case 2 CS3 MgBr can be attacking here, so answer would not be 2, rather it would be 3. Okay, so let's see how many CS3 MgBr can attack on this compound. We have something like this, and SH here and OH here. So how many? Obviously one can attack here, one can attack here, okay, another can attack here, another can attack here, another can attack here. Total answer would be 4. Let's see another example. Here we have something like this. OH here, okay, and this group here. So how many total? Now in this case, what we'll do is, one can attack here, two can attack here, okay, then one can attack here. What else? So we can have two here, okay, because they are two double bonds. So what, in first case we'll have something like N minus CH3 here. N minus will again take H plus, so it will convert into NH. Again one CH3 can be added here from the Grignard reagent, and again this bond will break itself and will have negative charge again here. This will again attract a H plus toward itself. So 2 here. So 2 plus 2, 4, 4, 6 in this case. Oh, this also can have 2 here. This also can have 2 here. How? Suppose we have something like this. CS3 minus is attaching itself, so we will have something like CH3 here, and we'll have a negative charge here, okay. So we have to check for whether this compound actually undergoes CS3 MGBR or not, okay. So if it does goes, then we'll have something like a CH3 here. This is R group here, this is R group here, CH negative, and it will take another Mg plus Br, and we'll get this as the product, okay, or intermediate. So we need to check whether in this case we have something like so in this case we need to compare the acidic strength actually for CS3 minus, or the basic strength between CS3 minus and C double bond C minus. So if you look at the acidic strength, CH4 is less acidic than CH2, right? Okay, so this would be actually basic strength would be of this order, hence this can also be converted into CH minus. Okay, so here also we can have 2, hence in total we will have 2 plus 2, 4, 6 and 7. 6 plus 1, 7 is the answer here. Okay, let's look at another example, and the last example for this video lecture. We have something like this and CS3 MGBR. So how many places are there? The answer would be 2. First it attacks on here, it gets a negative bond here, negative charge here, again it forms double bond here, and with the this would be a leaving group, and again it can attack on. After this leaves, we would have something like this situation, and again it will attack. It will again form a CS3 here. So answer would be 2. Okay, so with this we come to the end of this lecture. In the next lecture we will be continuing on practicing the same examples. So till then, good luck and goodbye.